Here we see a reference circle representation of the sine of theta equals 0.61, assuming that y equals 0.61 all the way along this line here. Then this angle corresponds to our 39.6 degrees. This to our 180 minus 39.6, 141.4 degrees, or whatever it was. I guess it was 37.6 and 142.4. As a matter of fact, there are the numbers. If we look at the graph that's constructed by imagining that we move around the reference circle and follow the y-coordinate as we move along the theta axis here, we see that the point where the 0.61, y equals 0.61 line crosses the graph, the first point is going to be 37.6 degrees. Theta equals 37.6 degrees. The second point at theta equals 142.4 degrees, corresponding to this position and then to this position on the reference circle. If we move along the graph, we then complete a cycle here corresponding to a cycle around the circle, and then we go a little further corresponding to this distance, and we're at our 397.6 degrees. If we go around to here, we're at our 502.4 degrees, etc. So this is a graphical representation of what we've just seen about the sine function. Now, everything we've done so far has been a pretty concrete example with angles and everything. We could represent our solutions to this point by saying sine theta equals 0.61, so theta is the inverse sine of 0.61, or 180 minus the sine inverse sine of 0.61, or 360 degrees, plus the inverse sine, or 540 degrees, minus the inverse sine. In general, n times 360 degrees plus the inverse sine of 0.61, n plus 1/2 times 360 degrees minus the inverse sine of 0.61. This one corresponding to n complete cycles, and then plus this angle, or n½ complete cycles, and then you have to backtrack through that angle for the reasons that we've already seen. There are cases where we, of course, work in degrees, but more often when we're dealing with angles and graphs, and angles past 100 or past 90 degrees are outside the range of the basic inverse function, inverse sine function. We're going to talk about radians. So instead of 180 degrees, we're going to use pi. Instead of 360 degrees, we're going to use 2 pi. Instead of 540 degrees, which would be n plus 1/2 revolutions, we'll use 3 pi. And again, excuse the errors here. That's a minus sign. That's a cross out. Had a plus there. Theta is then going to be, in general, n complete cycles, which is n times 2 pi radians, plus the inverse sine of 0.61. Of course, we can write that as 2n pi plus the inverse sine of 0.61. Or n plus 1/2 revolutions, n plus 1/2 times 2 pi minus the inverse sine. Now, n plus 1/2 times 2 pi could be written as pi times 2n plus 1. Again, there's a scratch out. So we can have the formula in this form.